In this video, I'm going to go over the degree of a polynomial and whether it's even, odd, or neither algebraically. Now, the first thing I want to take care of is doing the degree. Now, the degree of the first polynomial is 4. Now, this is different than what we've been doing because we've only asked for the degree in factored form. This is in standard form. In standard form, the degree is the highest exponent. So, the degree here would be 3, and the degree here would also be 3. Now notice this is an even degree for the first one, an odd degree, and another odd degree. And this is good to know because we're going to analyze whether the function is even, odd, or neither algebraically. Now we've done it graphically. Remember, even has symmetry over the y-axis, and odd has symmetry over the origin. But there's a way to do it algebraically, and the way that we do it algebraically is we substitute negative x into the polynomial. Now the reason why we substitute negative x in is because if your value, say you were here at positive x, if you negated that x and you were still on the same level but the opposite side, that means you would have symmetry over the y-axis. If you negated x and you were here and you became over here, you would show symmetry over the origin. And that's why we negate x. It shows us how the symmetry would behave on the graph, but this is an algebraic approach. So what I'm going to do is I'm going to replace the x with a negative x. And I'm going to see how the signs change or stay the same. If you negate, if you raise x to the fourth, negative x to the fourth, you would have 4 negatives inside of that parentheses. The 2 would become positive, because a negative times a negative is a positive, and these 2 would also become positive. So ultimately, nothing has changed. So since the signs are exactly the same as the original, your function is considered even. So the way we state this, we would say the function is even because f of negative x is the same thing of f of x. So no signs have changed. So to do an odd degree polynomial, you do the same exact thing. You would plug in negative x, where you see x. So the first piece, you would have 3 negatives, because it's cubed. The negative and negative would become a positive, but this negative would win, because a negative times a positive is a negative, so negative x cubed comes out. I have a negative 4 and a negative x, meaning a positive 4x. So now looking at my new polynomial, I see that f of negative x is directly the opposite as the original of f of x, meaning that this is a negative and that's a positive, this is a negative and that's a positive. So since both signs have changed, that means you have symmetry over the origin, and that means you are an odd function. So I would say an odd function because f of negative x is equal to the negation of f of x. So meaning it's equal to the negation of the original. So that means this is negative and that's positive. So for the last one, I'm going to discuss neither. You're going to evaluate the same thing, negative x. We're replacing each x with a negative. This is kind of confusing because it's already negative, but we're replacing this x with a negative. So this is going to become 2. This is 3 negatives. So like the last time, ultimately it will become negative x cubed. So that's multiplied. So it'll become negative 2x cubed plus x plus 2. Now if you notice, something's up with this problem. The first sign changed from the original, the second sign changed from the original, but the third sign stayed the same. Therefore, there is no symmetry on the graph because the third sign did not change, or these 2 did not stay the same. So because that happened, we will say our function is neither even or odd because when you did f of negative x, it did not equal f of x, which is the even condition, and it also did not equal the negation of f of x, which is the odd condition, so it's considered neither even or odd.